Good afternoon. Last class we have seen about the free body diagram concept, how the reaction force acts on the lying plane, and how come we are identifying the angles after drawing the free body diagram. Now we'll see the tensions and the friction force acting on an object. The friction force always acts on the contact point. The objects in direct contact with the body can also exert friction force on the body, which resists the two bodies sliding against one another. This force will always perpendicular to the surface in contact. Friction is the subject of N to the entire surface. For smooth surface, we assume that there is no friction. For rough surface, we assume the bodies will not slide relative to one another in no matter. In the case of friction force, is always just large enough to prevent the sliding. Tensions. The tensions will act on the opposite direction to the weight which is falling down. Here we are able to see that the traffic light is hanging. There are two different cables where at two different angles, and it is supported with the end point of the cable. Here there will be a support at the end point of cable which holds the traffic light from freely falling down, so that the tensions in the cable will always act opposite to the falling direction, like this. So we are drawing the free body diagram like this. Later on, according to the necessity of solving the problem, we have to identify the angles. We'll see a problem in detail. Here, we have to design a complex scenario involving interacting object forces and sketch the resulting free body diagram and analyze the angles between the forces and the reaction forces. Here we are able to see the diagram. This is the diagram. As already we've seen that the weight of the object always falls perpendicular to the ground. And the reaction force are the normal reactions perpendicular to the lying plane of the object. This ball is supported to this vertical wall. So we here also will have a reaction force like this. And now we are able to see that this ball is not falling down because the ball B or this ball is supporting to prevent this ball to fall down. So there will be a reaction forces acting in between these two balls. Either one of the ball will move upward, the other one will move opposite on the same line of action downwards. We have to assume the directions accordingly. So we are writing down our assumptions. Reaction force at point C as RC, and the reaction force at point A as RA, and the reaction force at point D to E as RED, and RDE, the weight of the ball WD. The weight of each ball is of 50 Newton. The W value will be of 50 Newton. By considering all this, we have to draw the free body diagram and we have to identify the angles, and then later on we have to solve the problems. Here, we have to see the number of forces acting on each ball. In ball C, there are only 3 forces acting: weight, RB reaction force, and RED is another reaction force. Whereas in the ball D, there are 4 reaction forces acting on this particular ball. So while solving the problem, first we have to consider the ball C. We have to consider this ball, and then we have to solve the problem accordingly. We have drawn the reaction force over here. It is given that the angle is 30 over here. So this shape is of right angle triangle. Since the normal reaction force is acting over here, this angle will be of 90 degree. So the another angle will be 60 degree. And we'll get the angle as 30 degree over here. And this angle with respect to x-axis is 60 degree. Since each quadrant is of 90 degree, this one is will be of 30 degree and the another angle will be of 60 degree. The reaction force and the tensions acting between the each ball will be of perpendicular. So since it is 30 degree, the another angle will be of 60 degree and the rest, the angle with the x-axis of 30 degree. So by resolving a force method, we can write the equation as sigma FH is equal to minus RED cos 30, minus 50 cos 90 and minus RB cos 60. That is equal to 0. Since the system is in equilibrium, we have to write down the conditions of equilibrium. Sigma FH is equal to 0, sigma FE is equal to 0, R is equal to 0. We can also write down the equation for sigma V. By solving the equation 1 and 2, we'll get the RED is equal to minus 25 Newton and RB is equal to 43.30 Newton. Since the value is in the negative, the assumed direction for RED is wrong. We have to assume the direction as like this. The assumed direction is now downward direction. We have to assume the direction as upward direction. Then we have to solve the another ball. Here also we can apply the concept by identifying for identifying the angles and applying the concept of conditions of equilibrium. Sigma H is equal to 0, sigma F is equal to 0, and the resultant force will also be 0. The forces act between the RDE and RED will be equal. So we can take the RDE as minus 25 over here, sigma H equation and sigma FV equation. We'll get the equation as sigma FH equation as RC minus RB cos 60 is equal to 25 cos 30. And we'll get sigma FV by substituting the known values in the sigma FV, we'll get the RA value as 72.16 Newton. The 72.16 Newton can be substituted over here and we'll get the RC as 57.3 Newton. And then we can write down the results and we'll complete the problem. Thank you.